Hello guys and welcome back. If I remember correctly, last time we've just finished up the address space stuff and we fixed up all the build issues. So today we are going to give it a test to see what we get. So let's get started. Alright, let's try to build this and see. Okay, so it does look like it's built with no problems. And if I start the virtual machine, it does what it's supposed to do. So that's pretty cool. Okay, so let's get cracking. Right, so I guess first we need to import address space, import that's under address space. There we go. Oops, there we go. And if we go down somewhere around here, we can go ahead and create address space. And that would be address space. I think we call it create. Yeah. And of course here we need to catch that, do some of this, and of course could not create address space. Yep, looks good. Right. So now let's try to map a few addresses first to see what we get. So 4, I'll go from 0 to 10, capture that under I, and let's do const p address, and I'll map 1, 2, 3, 4, 0, 0, 0. Just want it to be page aligned. Actually, let me just do something like this to also test that it's correctly page aligning the addresses we are mapping. And we want the address to be, actually, hold on. I want this to be plus I times the size of a page. There we go. And actually, this one would just be this for simplicity. So address space mmap. So this takes a v address, which is address. V adder is equal to, and I guess we bitcast that int to the struct we need. Right, this one here would be p-adder, and this one would just take the, I guess we are going to need to do an int cast on it, since it's probably thinking it's a u size of p-address. There we go. And then we'll need flags. For flags, we are just going to take present flag and read write as read write. There we go. That looks okay. This function here returns an error probably. So let's catch that and do something with what should we do here? So probably here we are just going to continue. And here we are just going to not map p address, or rather v address, something like this, to p address 0x hex. Oops. All right. There we go. So v address comes first, and then p address. Cool. And I'll probably just do one. There we go. Right, looks good. So let's build this and see. All right, we do have a few errors here. Right, so expected U64 found, whatever that is. And I think that's in create. Yep. So here we needed an end from pointer. I think that's okay. And union type does not support field access. Okay, so 106. Right. Okay, I see it. So here we need to actually return that. Yeah. All right, let's see. Okay. Expected a pointer to mapping entry, got a pointer to mapping. Okay. Right, so I think that's here. Right, so for this level here, I don't think we need to get the mapping. Actually, let me check on the C implementation. Map to address. So we get that, and then we just get the entry within it. Yeah. So here we are getting all 3 levels, and here we just need to actually get the ID from within the level 1, which is basically the page table. So this would be PD mapping, mappings, and then virtual address dot PT index, and probably this we take the address. Right. Yep. Yep, it looks pretty good. That looks pretty good. And actually, I think we are... yeah, the naming is wrong, I think. Because this is PML4 mapping. This should be PDP mapping. Right, and this should be PD mapping. And this is the page table mapping. Right. And this here would just be entry. Right, so let me fix up all these. So this would be PML4 mapping. This would be PDP mapping. This would be PD mapping. And this would be PT mapping here. Yep. Right. I think that's what we need to do. Okay, so it builds. So let's see if we can run it. Okay. Well, the good news is it's not crashing. The bad news is we don't know what it's doing. So let's make sure we know. So if I go to main, I just want to go after all this, and I just want to do something like address space dot dump, I guess, or print. Print. Great. So let's add a print function here somewhere. Probably, yeah. So public function print takes a self, which is a const pointer to self, and it returns nothing with no errors. And what we are going to do is basically walk the pages, and if we find a page that's present, or rather walk the entries, if we find an entry that's present, we are going to print that entry, and if it's not present, then we just move on. Right, so for I guess we could do for entries self dot. Oh, right, I need to get the mapping first. So let me just go ahead and do this. Right, so now we have the topmost mapping. So we can do for PML4 mapping dot mappings as mapping. Yeah, let's call it that. Actually, we could do something better here. We could do PML4 mapping dot print. Right. And now we can just go here to page mapping, and we can add a public function print that takes self, which is a const pointer to page mapping, returns nothing. And here we can just go ahead and do for self.mappings as mapping. And we can go ahead and do stuff. Right, so what we want to do here is if mapping dot present, if it's, or rather, let's check the other case. If it's not present, we just continue. If it is present, then we probably need to get the mapping from inside that mapping and recursively print it. Yeah. So that's what we're gonna do. So we're gonna do const address is mapping dot get address, right? And we know that this address exists because we are present. We have the present bit set. So next we are going to take that address and convert it to a pointer. I'm just going to go ahead and grab that from here. Right. So pointer from int, that gives us a pointer to page mapping. Cool. So where were we? We were somewhere here. Right. So that would be const. Let's call it next level mapping. And this is a pointer to a page mapping. Actually, we don't need that anymore. We can just go ahead and do mapping.getAddress. Right, and now we are just going to call, next level mapping, but print. And this would just recursively go through all the levels and print all of them. But we need an exit strategy from this. We need to know when we are the highest mapping or lowest mapping to basically break out of this loop here. And how do we do that? So let's create a function here, call it print, or let's call it underscore print. It takes exact same thing, so const page mapping, and it takes a current level, which would be just a use32. Hold on, what did we set as our U8? Okay, so it can be a U8. So a U8, and this also returns nothing. And this would basically just track the levels for us. So this would go to here, and this would basically just forward the call to underscore print with self dot So I guess we still need to get the levels. Okay. So maybe we can just get rid of that, do that, and current level is just quite level. So if level is if level is less than 1, I believe, we'd want to just do actually this would need to go inside here. So we need to do mapping.print. Right, so this would be print the entry itself, since we should be at the page table. Right, otherwise we keep basically doing this thing here where we go one depth level deeper, and I guess we just need to pass it level -1 to print. Yep, that looks okay, I think. Right, so here we are going to go to this entry here, create pop function print. So this takes a self, a pointer to entry, and nothing else, and returns nothing. So here we probably would need to do something like this. Can I specify that it's const? No, I can't. Maybe if I type it correctly. No, I can't. Okay. Right. Okay. So this would take a const pointer to entry then. Right. So here we are just going to do stud or we can use our logger, I think. So debug or maybe info, and we can do I guess we should just print the actual address, and then we should print the whole struct as a U64. So entry maybe we should just print that. So address is 0x hex, and then we should do something like this. Yeah, it looks pretty good. So this one here would be the self.get address, get address, and this other one here would be at bitcast or as AU64 at bitcast. Well, I guess self. Yeah, that looks pretty okay. And I guess we could get rid of that other window. Right, so we should be okay. But we also would like to have the actual virtual address that we are currently looking at. And to do that, we are going to probably do, all right, let's go, the address. This would be a PML4 virtual address, and we just zero initialize that. Can we do that though? I think we can, and I don't want the undefined. Actually, let me just check that we don't have undefined anywhere on the structs, and we don't, so that's fine. Right, so we create this virtual address, and we are going to right, so we are probably going to need to switch on the level. So if we get level 4, we want to do the address dot PML4 index is equal to and actually we need that to be done after this. So this one would be mapping dot ID, or the actual ID of the mapping. So I guess we should do this, and we capture that as index. Right, so at int cast index, yeah, actually we don't really need these braces or these. Right, so for 4, we want to do that. For 3, we'd like to do the same, but for the PDP index, int cast index. For 2, we'd like to do pretty much the same. But for the PD index, and for 1, we'd like to do the same, but for the page table index then. So in cast index, and then for 0, I guess, we want to do this. We want to return this, basically. Right. And so this doesn't exist anymore. And of course, I'll just add a an else branch here. So else, this would need to be unreachable. We are pretty sure of that. Right. So once we go through all of that, we should have our virtual address, because it's just this struct here converted to bitcast to a U64. Right. And since we know that it's present, so we can just go ahead and I guess we can go ahead and print something. So log.info, and we could do the address. Maybe we just do these. And we could do something like this. Yeah, looks okay. So let's do, so as U64 add bitcast of the address. Oops, the address. There we go. So that looks okay. We are still going to need to actually, we don't really want to do that here, though. We really just want to do this right before we print. So let's do this. Let's go there, do that, and do that, and then we would just do, oops, there we go. Something like that. Of course, this one here would need to have that. There we go. Looks okay. Let's build this and see what we get. All right, so a few problems here. Member function expected one argument, found 0. Okay, 159. 159. Right, so this would need self.levels. True. Okay, let's see what we get next. Pointer capture of non-pointer type. Right. Okay. So that should be here somewhere. Well, I guess we could get a pointer capture if we do something like that. Cannot bitcast from const address space entry. Yeah, you can. Oh, because it's a pointer. Because it's a pointer then. So can we do something like this? Okay, looks like it's happy. So let's run this and see. Actually, are we calling this anywhere? Yes, we are. Okay. 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 Cool. So we do get something. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10 pages mapped and we have 10 entries printed, but they're all wrong. Okay, so let's see what we get. What are we doing wrong there? Should we probably do something like log debug, and we do mapping, and we just print it as an any, and we do mapping up. Right, so let's do that. Okay. Right, let's see here. Where's the first one? This one. So we do have an address. I'm not sure if it's the correct address, but we do have an address. Okay. Okay, so the mapping is correct, I think. Can we also go ahead and print so log.debug entry something like this and self maybe. Oops, let's build this first. All right. So I'm looking for entry mapping entry. Let's move this out of the way. Okay. Well, first of all, that's not good. We have shit written over the padding. Yeah, that's not good. That is not good. Okay, so if we print the virtual address we get so far, let's see what we have. So any, I guess, don't really care. And this would be the address. All right, let's see. Okay, so starting from here, we get all zeros. That's okay. But we keep getting all zeros. Right, okay, I see what the problem is. I actually do see what the problem is. We are doing recursion, so we are going to need to pass a pointer to this, or at least this value here to the next levels. Okay. So let's do something like the address, which would be a nullable PML4 virtual address, I guess. So if the address opt, or rather if not the address opt, we go ahead and do so the address is just that. And yeah, looks okay. And so here we do the address. And we should go all the way down here somewhere over here. And we do null. That should be okay, I think. So let's see. Okay, so he's not liking that for some reason. Expect bool, right, so I need to explicitly say that it's different from, so it's not equal to null. Cannot assign to constant, of course. Yeah, so I guess we are going to have to pass it as a pointer. Right, so if that is not null, then that pointer would need to be, or rather we would want that to be a pointer to a new value we create. Kind of assign to constant. Not sure what I'm missing here, but okay. So that's not a constant. And now I don't need to do this. And I don't need to do this either. I guess we should just go ahead and change this to so address of some value we create. Okay, right. So if we don't explicitly say that this can be a variable, so the address is oops. Okay, what's going on? And this should be a pointer to, or rather, this would be a page mapping. No, this is a PML4 virtual address. And this would be a pointer to that, to the address. All right. Okay, so let's see if we actually do get something now. So the address, we can see that the page table index is now actually moving. So that's good news. Right, so let's bring back the logging we had here. Let's maybe remove this for now and put this back. And just comment that out. And let's see what we get. Right, so we cannot cast it now because it's a pointer. So where was it? This was it. So let's deref it, and we should be good to go. All right. Okay. The virtual addresses are now getting correctly computed, but the mappings are still shit. Okay. Right. So I guess if the mapping itself is shit, so let's do this. And we can go ahead and take a look. Oops, let's build it first. Take a look again at what the entries themselves are. No, I think we are doing something weird here. The entries are not good at all. Right, so let's bring out the big guns, I guess. We can go here, and we can do this. So log debug PML4, and we print its address. So that would be what was the address? So I guess PML4 mapping, but this one here would need to be this. Yeah, it looks okay. So this one here would be BDP. This one here would be PD, and this one here would be page table. And then the entry we get at the end here, I guess we should go ahead and log debug it entry after mapping is well, I guess any, and we can do something like entry there. Right. Okay. Right, so let's see what we get. Let's start with this one here. So entry is, wait, hold on. Yeah, so this is what we are looking at. So allocate one page for address space, PML4 is at this address here. PDP, okay. Hold on, let me check something. All right. PDP mapping. PD mapping. And PT mapping. All right. Let's try this again. Okay, so where are we? Okay, so we do allocate pages for every level, and after the mapping, the entry has address 4660 and that have present true read write is read write. Okay, looks pretty good. So actually, what I want to do here is go back and just do this. So as U64 bitcast that entry or what's inside the entry. Right. Okay. Okay, so let's try this again. Okay, so we are mapping 1234000. So that's good. That's good. B, C, D. So we went from 4. Okay, yeah, that looks pretty good. 10 pages. So now why are we getting this entry here that's not the wrong, or rather that's the wrong, I think its pointer is not good or something. Because for this address here, virtual address 000, we should be pointing to basically this entry here. That's so 1, 2, 3, 4, and then 003, which is present and read write. But this entry here has user supervisor as user, has write through and cache disable, all these things, which leads me to believe that this is not the correct address for that entry. Okay. Well, at least we know what's wrong. Right. So I guess somewhere over here, we might be doing something weird. So here we get the page table. Oh, okay. So maybe I think I know what the problem might be. So let's do this, and then here we get the so const entry is self.mappings at, or not self, but mapping.mappings at index. What would the index be? Well, I guess it's the address. I guess it's that, right? And then we could just do entry.print. And we could get rid of these. Maybe. Yeah, that's not it. That might be it, but let me just try something before. Let me just try to print the actual address of the mapping. There we go. I guess that would be the fastest way to know if we are on the right track. Right, so let's do this. Okay, so here for this first address, we want the mapping to fall here. So 5D, 5230. And what do we get? 5. Okay, well, we are way off. Way off. Oh, hold on, wait. 5D, 5230. And then the next one would be 51504F. So 5251504F. That looks okay. And then we would need the address of the entry. I guess we can do something like this for the address of the entry. Okay. All right. Let's see. So what do we have here? We have 45444342, and the entry is at 42. Okay. And here what we have is 4543444342, and the entry is at okay. Well, we go one step further than we should. Okay, so it's what I thought we were doing. Once we get to level 1, we should just get the entry directly from that level, and not go one level deeper. Because if we go all the way to level 0, then we are getting the address from the actual physical address. Okay, so that was an easy fix. Yeah, it wasn't. But here we can see that we do get the actual entries with the correct values. So yeah, it looks like our mapping is correct. But before we move on, let's do a slightly larger test, which would be us just mapping a few more pages, or I guess pages in virtual addresses that are further apart, just so we can see that we are actually doing things correctly. So let me do this plus that. And I guess we can just put this back because we know that it's correctly aligning it down. Right, so let's try that now. Okay. I guess we're gonna have to try a bit harder. Let's add this and let's add that. Okay. And we're still just allocating one single page for each of the levels, which is kind of weird. I'd have expected to at least get a few pages for the page tables, since we are so far apart, but maybe not enough. So let's try a bit more. So let's do C0. I'm expecting at least a few allocations for the page tables. Huh. I guess we don't really do that for some reason. I'm gonna have to print the virtual address. So, page table. Yep, something is weird. Because here we get the first PML4, but we need the 257th PDP entry. Which we allocate here, I'm guessing. But oh, okay. So they all fall within the same. Yeah, they all fall within the same range. Okay, so let's try something else. Let's try to do a second loop with addresses that are way farther from the first ones. All right. Let's see. Okay, so we do see a few allocations here. So PDP, PD, and PT are all reallocated because they have changed. Right. Okay. Cool. Cool. But do we actually see our addresses here? Yeah, we do. Cool. So I guess it all works. Well, that was pretty much it for today. If at any point you've liked this video, please subscribe, leave a like and a comment down below. This was writing a UEFI bootloader from scratch. Falcon out!